Greetings folks. In this tutorial we are going to talk about a very popular topic, that is data science with Python. And if you are actually a complete beginner, that is you don't have any prior coding experience or you are weak in mathematics, it doesn't matter. It's not actually that hard. So we'll see that. So at first I'm assuming that you are a complete beginner, so we are going to use Jupyter notebook. Therefore just head over to Analytics.com, then under this products tab go to individual edition. Nice, then scroll down and where is it? There it is. So depending upon your platform what you are using, Windows, Mac or Linux, I'm gonna use Windows, so download it, and after downloading it, install it. And once you are done with installation, then go to this search bar and just type Jupyter. Okay, open it. That's it. This is here in front of you. It's called a Jupyter dashboard, and now you can navigate to the any folder or you want to start your programming. So I'm gonna use my desktop. I've created a folder here, data science files, and now I'm gonna create a new notebook. So new Python 3. Okay, fine, there's a little bundle of joy. So this is our Jupyter notebook. Now we can start our coding right here. Okay, so let's get started. So to print anything we can write pri and print, then in parentheses you can, in quotation you can write anything you want, like hey guys. Then to run this cell you can just run it from this run button, but we are gonna use just shift and enter. So what, hit shift and enter. Okay, that's it. Now you can change it to anything you want. Okay, it will be printed. So now we are going to talk about variables. Variables are nothing but to store our data temporarily in our local computer. Let's say I want to create something, and let's just say 10, a number, and I want to store this 10 in a variable called x. Cool, it's stored. Now you can print x, print print x. Okay, now in Jupyter notebook you can directly just write x and it will be printed. You don't need to write print. But if you want to print more than 2 lines in one single cell, let's say y is equal to 5, then you want to print x and y, so print x, then print y, then x and y are printed. Okay, so we don't need now x. Now you can see the type. There's a function called method called type to know the type, what called this x, what is known in Python x. So type of x is integer. X is known as integer. So integers are actually a whole number with no decimal points. Let's say 1, it's an integer. So okay, fine. Now integers are known in short as int in Python. Okay, so now if you change this 1 to 5.12. Now let's see the type. It's float, or floating point, in short float. So numbers with decimal points are known as float. If you write like 5.0, it will also be a float. Okay, that's it. Now if I quote this 5 in a quotation, okay, now let's see what it is. It's a string, or str in short, string. Okay, now strings are anything that are in quotation in Python. Let's say any text, txt text, it's also a string. So if you pass a value within this quotation, it will also be interpreted as a string. Just 5, it's a string. Okay, now you might be wondering, why do I am required to know this data type? Because if you are going to continue in data science, it is one essential part to know the data structure, actually data, what type of data it is. And this, let's see one example. Let's say I want to print value. It's a string, so I want to concatenate it with, or add it with 2 plus 2. I want to add it with plus 2. Let's print it. It will return you an error. So can only concatenate a string to a string, not integer. 2 is an integer, so you can't add or multiply two different things. So to do that, we can do that. That's the way. Just convert this 2 into a string. Yes. So to do that, str in a parenthesis. Okay, now do that. Now it's okay, because now we are treating this 2 as a string, so it's okay. Both of them are string. Now you can see that we can convert a value, either an integer or floating point, but we can convert both of them into a string, but we can't convert a text into an integer. Let's see that. Print 2 plus, so 2 is a integer, so I want to convert our text into an integer. So let's see. No, it's invalid. Okay, alright. Oh, I forgot to change the name. Okay, change it to whatever you want, like tutorial 1. Okay, fine, cool. Okay, there's another type of value name that is called Boolean. We'll see that in a minute. Okay, now let's see some printing techniques, basic printing techniques. For example, you have, say for example, the price of an apple is $1. Value is $1. So I want to print that like the value of an apple is what? I want to print that value, whatever it is. Okay, let's see what it turns out. Oops, it's just provide that as it should be. But if you give write one if at the beginning, then now see what happens. See, it's now printed 1. Now if you change it 10 here. Cool. That's another technique. Same thing you can do by another way, like what? The price the price of an apple is what? I want to print that value, so just put a comma here, then print the value, or give the variable name, then again one column, comma, then the string you want to provide, $. See, same thing, but in two different ways. There's many other way to print, but we are just going to say this two. Use this two. Okay, now let's see what a tuple list in Python. So at first say tuple is, the tuples are constructed by in a parenthesis. You can provide anything you want, 2, 4, 6, etc. Or you can also provide a string here like name. Okay, now print it. Now you can see the type of this tuple by type method, built-in method. It's in Python, typ type of tuple. That is my variable. It's a tuple. See. Okay. Another thing, these tuple, list, set, and what? Dictionaries are actually fundamental data structures in Python. So I'm gonna make a list, and the lists are constructed within a square bracket, and similar to tuple, you can provide anything you want. You can set here, write here a Boolean, a name string, or anything, 2, 4, 6, 8, or just a name, let's say Tom. Okay, now type of this list, LIS, it's a list. Another difference between tuple and lists are actually tuples are immutable. You can't change tuple. You can't add something in this tuple. But lists are mutable, changeable. You can add here something else like 6, 8, 2, 10, 12, and anything you want. And you can remove some elements from this list. But from tuple you can't do that. So let's see that. List lis dot append. Let's append function to add values. So let's say 10. Now let's see our list. See, 10 is being added. Okay, but if you do the same thing for our tuple, tup dot append, let's say 10, it will return you an error. Tuple object has no attribute append. That is, it's not appendable. Okay. Now you can remove from list elements from list. Let's say you want to remove rem. Remove 2. Alright, let's see our list. See, 2 is removed. Fine. Okay. Now let's create a new list. Say for example 2, 10, 4, 5. Okay. Now run it. X dot if you want to apply any function on that list, you can just hit tab button and you will see all the methods that are related that can be applied on that list will pop up. So let's say sort. Now let's see x. See, before that 10 was in the middle section. Now sort it in ascending order. Okay. Fine. Now there are many things like length function is a built-in function, length of x. See, 4. There are 4 elements in this x list. Okay. Now it's time to talk about indexing. Okay. So what again, let's see x over x. Now if you write, so indexing is done by a square bracket syntax. In this square bracket, if you write 0, you'll get the first element. So in Python, indexing starts from 0 for the first element. Okay. Now if you write x 4, it will give you an error because there's no index. Index is out of range because 0, first one is 0, then 1, 2, and this last one is 3. So for the last index you have to pass 3. 10. That's another way to extract the last element. It's -1. See, 10. Easy. Okay. Now for indexing, I'm going to make a NumPy array. NumPy arrays are actually faster and easy for calculation purposes. So to create a NumPy array, you have to first import NumPy library. So we are going to import it. Import NumPy as NP. So NP is actually, you can say that it's a short name of NumPy, and it's a common way to use NumPy. Okay, import NumPy as NP. Now we're going to create one variable x is equal to np.array. Array what? Array. And in this array we are going to give a list. That's a 2, 4, 6, 8. Now let's see our x. New x. It's NumPy array. Now if you see the type of x, it's a ND array, that is an n-dimensional array, NumPy array. Okay, now if you want to see the data type, x.dtype, it's integer. Okay, fine. So you can say that NumPy has its own data type, and it's not a method, it's an attribute because it doesn't take one parenthesis in front of it. Okay. Now NumPy arrays are actually homogeneous in nature, because what I mean by that is if you put one floating point here, then the data type will be changed to floating point. That is, it will store the data in one single data type format. Now let's see that. See, now the type is float. Okay. Now I don't want to keep that. Fine. Okay, now let's see index. Oh, another attribute in NumPy is shape. Now see it's 4. Another thing it's done, and now you can see the dimension of this matrix or array in dim dimension 1. It's a one-dimensional array. So our X is a one-dimensional array, and that shape means in our first dimension there are 4 elements along our dimension, and we have only one dimension. Okay, fine. Now let's see indexing, slicing, array slicing again. X. Okay, now array indexing is similar to what we have seen before in list. 0 for first one, -1 for last one. Okay, now if you want to slice, that is, you want just this 2 or this first 2 element, how can I do that? For slicing purpose we use this colon. Okay, now we want this first one and second one. So normally what we do is 0 to, this is 0th index and this is 1, so 0 to 1. But it returns us just one number, that is 2 in index 0. So in Python doesn't count the last index or upper bound of the slicing parameter. In slicing case, that is, if you want to extract a range of values, then upper bound will not be counted. So if you want to select this 4, you have to provide 2. Now you see 2, 4. Okay, fine. Now if you want to start your slicing from the 0th index, then you can omit this 0. Okay, it will return you the same result. Fine. Now let's say we want to slice 2, 4, 6 at a time. 2 to 6. So 0th index 1, 2. So 6 is in second index. Fine. So that's it is due to second, we have to provide 3 because second will not be counted. See the same result. Now if you want 6 to 8, so 6 is in second index and 8 is in fourth index, third index, so you have to provide 4. See, 6, 8. If you provide only 3, then you will see only 6. 3 it will not be counted, so you have to provide 4 to count the third indexed element. Okay, I think now you're clear about it. Now let's create a two-dimensional array. So to do that, let's y np dot arrange. Let's say what 6 dot reshape it to 2 by 3. Let's say y. See, now if you want to see the dimension y dot dim ndim, it's a two-dimensional array 2. Okay, let's see the shape of this matrix. Y dot shape, it's 2 by 3. That means we have 2 elements along our first dimension and 3 elements along our second dimension. So here our first dimension is our row, so we got 2 rows, and second dimension is our columns, we got 3 columns. Okay, fine. Now what? Now let's see how we can do slicing into dimensional array. Let's increase it to 5 by 5. 5 by 5. So now what? How? 25. Let's say 5 by 5 matrix. Dimension 2, shape 5 by 5. Fine, cool. Okay, now we want to slice it. Slicing here, actually you want a subset of your data. That's it. So let's say you want just first 2 columns from your y array. So y in a square bracket. Here we have row and column. So first is for row, then after comma another slicing, this is for columns. So first one we will use for rows, after this comma, second part we will use columns. So as I said, we are going to use all the rows. So to specify all the rows, we just use one single column, and we need first and second columns. So how do we do that? Starting from 0 index, and second column's index is 1. So we have to pass here 2, because the outer level or outer bound will not be counted. See, this is our first and second column. Okay. Now let's say you just want to extract the last column. See, this is the last column, 4, 9. So we kept all the rows, actually row values, for this column, this 4, 9, what in last column. Okay. Now if you want to extract or keep just last 2 columns, how do we do that? So to do that, we want to keep all the row values and just last 2 columns. Okay, so this is index 3. So 3, 2, 5, then 4 will be included. Nice. As I said before, that upper bound will not be counted. So the index for this column is 4, but if I pass 4, then it will not be added. That's why I passed 5. Cool. Now let's see why. Fine. Now there's another way of stepping slicing. It's a very cool one. Let's say you want to exclude this column, this second column. For example, you want to keep first column but not second column. Then again you will exclude, keep the third column but exclude fourth one. Again you will include or keep fifth one. So how do you do that? Stepping is actually by, so we want to keep all the row values, but we don't want this one and this one. So for stepping we use 2 columns. Okay, and says 2 for excluding 1 column, or you can say we are moving ahead 2 columns, this one and this one, and we will count the second one. Okay, just let's see that. Now see, we kept this one, this column, first column, but we excluded 1 step, 1 column, this one. Even I kept third and excluded fourth one. Now if you want to exclude the first row, you want from 1, then just specify the lower bound 1. See, you will only see 1 and 3, this column and the fourth column, second and fourth. Okay, so you can also here specify. Now if you want just this first one and fourth one, how do we do that? Then we have to go 1 step, 2 step and 3 step. So just write 3. That's it. 1 and 4 last one. Pretty simple. And I think you have to practice it more and you will learn more. Okay. Well, now let's talk about a little bit of mathematical operation in Python. Okay. So let's say if you want to add 8 plus 9, it's simple, just enter 17. And if you want to divide 9 by 3, just pretty simple this. Now if you do that like 7 by 3, okay, there's another type of division. If you write another slash, then let's see what it returns. It just provide you or give you the integer or the whole number. It doesn't include decimal point. Okay, in Python there's another mathematical operator called modulus. So let's see how it works. That's a 9 divided by modulus 2, and that will provide you just the remainder. Okay, 7 modulus 3, just the remainder. 5 remain modulus 2. Okay, now multiplication. In Python, multiplication is 8 to 16, and if you want to use the power, let's say 8 power 2 or 3, then you have to write this multiplication sign 2 times, then say 8 power 3 512. That's it. Okay, now let's see some NumPy multiplication addition tasks. Fine, so let's create new NumPy arrays, and then array, I'll give a list 2 4 6, and y is np.array 1 2 3. Okay, now let's add them. X plus y. See, NumPy add them element wise. 2 into 1, 2 plus 1 3, 4 plus 2 6, 6 plus 3 9. And if you multiply them like x multiplied by y, see, element wise multiplication. Now we can add them. It's 28, and the same work we can do by at once by just a dot product. np dot x comma y. Let's see, 28. But it's all about linear algebra actually, and we will not talk about linear algebra in detail in this tutorial. We'll cover those things in our second tutorial. But before we go ahead, let's see what are known as vector. So vector, V-C-T-O-R, vector. Let's create a vector. np dot arrange. Let's set 5 dot reshape. Reshape it to 5 by 1 matrix. Now let's see our vector. See, it's actually a 5 by 1 matrix, and this 5 by 1 or anything by 1 matrix are known as vector. Now if you transform it to 25 by 1, see, it's also a vector. So vectors are what? Vectors are actually a special kind of matrix that are n by 1 matrix actually. That is, n number of rows can be in a vector, but it will always have only one column. That's it. That's all about vector. Okay, now let's move on to one new topic. Okay, now in this lecture we are going to talk about if-else statement. So let's say we are talking about a speed of a car. So a speed is, let's say, 85. Okay, now we are giving some conditions. If speed is equal to, so for equality check we used double equal sign. If speed is equal to 99, then what? Then it's fast. Let's say print it's, what I'm doing, shit man, it's fast. Okay, now see, nothing printed because we haven't said anything about 85, but if you write here 99, then it will print it's fast. Okay, so we need to make it actually a fulfill statement. So now else, back to our, so you can notice here that we have 4 lines of indentation, 4 spaces. That okay, now for another new line, shift tab. Okay, elif speed, I'm going to give here a range of values. Let's say if speed is greater than 99 but less than 110 and less than or equal to 110. Okay, then print what? Then print it's risky. But if you provide a range of values, you have to make it a little change. Make a little change. So we are going to bracket for our first condition, then we will use another bracket for our another condition. Speed less than or equal to 100. See, and it's more readable. It's risky. Again, we want to include another statement, if speed is greater than, sorry, 100, let's say 10. If speed is greater than 111, always put a colon after you have done with your elif statement. Then you will have 4 lines of indentation. Okay. And if speed is greater than 111, then print it's too fast. Okay, now on another last condition is else if the speed is not 99, not in between 99 and 110, and not greater than 111, that is if the speed is less than 99. So else print it's safe. Okay, now let's see. Our value is 85, let's say it's 70, so it should print it's safe. See, it's safe. Now if we provide a 99, it will be it's fast. Now in range of values x 105, then it's risky. See, it's pretty logical thing, nothing else. So I'm not going to give you some more examples of if-else statement because it will waste your time. You can see the documentation if you want to. Okay, now let's move on to for loop. Okay, for loops are actually used to iterate over each element in a list or in a range of things. So we use, let's say we have a list 2, 4, 6, and we want to iterate over all of these elements 2, 4, 6. So how can I do that? For loop starts with for items, or whatever you can write here, or I in x. After that put a colon, give a colon. Okay, then 4 lines of indentation. For I in x, or items in x, print what? Print I. Now you can't print x. All the values of x are in I. Print I. See, 2, 4, 6. First iteration it prints 2, then 4, then 6. That's it. We're gonna actually again calculate the summation or add them up 2, 4, 6 in this for loop. How? Let's say sum is 0. Sum is 0. At first initially we set it to 0, then again sum is equal to our this variable sum, that is 0 plus I. So when you do that, at first our I is 2, so we'll add 2 with this sum, that is 0. So 0 plus 2 is 2. Then again in the second iteration our I is 4, so we will add 4 plus what? Sum is now 2, so 4 plus 2 it will be 6. And in the third iteration our I is 6 and sum is 6, so 6 plus 6 is 12. So our last summation product will be 12. Let's see. Oops. Oh, sorry, I have to print sum. That's it. 2, 6, 12. Okay, pretty simple. Now if you want to just print the last product, that is our sum, then we don't need it, comment it out. So to comment out it, just hit Ctrl and slash. Okay, so we don't want it, we just going to print sum 12. See, now we have something, a bigger number, let's say 10, 100, it will do the same as 122. That's it. Now let's do something more with this for loop. For I in, or you can say here, you can provide anything. Let's say x, just items. I just provide I. People provide I, give I. For I in range of values, range what? 10. So 0 to 10, that means range of values. This range function is used to generate range of values. So range 10, that means 0 to 10, but it will not include 10. I said you earlier that in Python, if when you use range of values, it doesn't include the upper bound. So let's see, print I. So it will print 0 to 9. See, 0 to 9. And I don't like this long printing style. Just make it horizontal. To do that, and is equal to see. So now you can do something else like 2 to 10, then it will give you 2 to 9. And if you want like 100, what I just passed here is actually I want 100 is very bad. 4. Okay, I want some range of values in between 2 and 10 or in the interval of 4. So I specified the interval is 4. Okay, so now let's say 100, and I want range of values in between 2 and 100 and within the interval of and in between the interval of 10. Let's see. Okay, that's it. Now let's do one cool thing for using this for loop. That is, let's say you want to know how many even numbers are in between 0 and 100. So let's write a program for I in range 100. So it will not include 100, that's why we'll use 101. For I in range 101, we need all the even values. Okay, so we are going to use if else statement in this for loop. If I is divisible by 2, that is, we'll use this modulus operator. I is divisible by 2, that is, our output will be 0. Then print I. Now see, I now we'll see they are all at the even values. There's no odd value. Now we wanted to know the number of even values. So to know the length of it, what we'll do, we have to store these variables in a variable, store these numbers in a variable. So to do that, let's initialize on empty list, that is x, and we are going to use our append function. So x dot append I. What it will do is actually, if I is divisible by 2, then append, that is, add those values to our x variable or to this list. Okay, now I don't want to print it. Okay, let's see our x. See, the same thing. And now if you want to see the length of it, len length function 51. So there are 51 values in between 0 and 100, even values. Okay, now let's give one another example of for loop, and I'm actually giving comparatively more examples of for loop because for loops are very important in machine learning or data science. You will see for loops frequently. So let's say I am creating on another list, and for I in range it's a bit different, and you will use such kind of for loops in when you are going to build your model by your own. Okay, so for I in range, what in range length of x. Okay, so range is also a function, that's why we have to put another bracket. Okay, so for I in range length of x, print I. So I is nothing, it's just 0, 1, 2, 3, because the length of x is 4, so it will not count 4 but till 3. Okay, but our intention is not just 0, 1, 2, 3, we also want to print x, but we will provide x, x of I. What I mean by this I is, actually I am telling Python to print the values or element of x which is in ith index, that is for 0 index print the first element from this list, then in the second iteration print the second element for this one index. Now let's see how it turns out. See, 0 a b c. Now if I didn't pass that I, let's see what turns out. What happens? Oh shit. See, what is this? It's actually just printing plain x 4 times, because our I is iterating 4 times. That's it. And make sure you actually you understand this function, because this program, if you don't right now, if you don't understand it, but you have to understand it, because in the long run you will use it more and more, this sort of function. And by the way, we can do the same thing by another way. Just let's say Ctrl B. Okay, for I comma, let's say v in enumerated, it's actually a function x print I comma v. So what does that mean? So for I is for index, v is for values. So 0th index is a, the second index is b, then that's it. So these are actually the same things. Alright, fine. Now there's another loop in Python, and it's known as while loop. And while loops are get executed when a specific condition is true. So let's say x is equal to 2, and I want to write like while x is less than 10, then I want to print x. So at first just make it 11. Now this cell will not be executed because our condition is false, x is greater than 10. That's why it will not give you any output. Okay, now let's say x is 4. So if now I run this cell will give you output F4, but it will be continuously running because this condition is always true. Because x is 4, it's less than 10, and it will run for infinite times, just 4 4 4 4 4. So we have to increment our 4 in each iteration. How do we do that? Let's say x is equal to x plus 1. That is, x will be incremented by 1 in each iteration. And this x plus 1 sign, we can write it in abbreviated form, that is x plus equal. And this is the same thing as x plus 1. Okay, let's see. Now see, at the first iteration x was 4 and it was added, 1 was added with it, that's why output is 5. Then after some iterations x becomes 11 and our while loop gets false and it will be terminated. That's it. That's all about for loop, and I'm not going to give you more examples on it. Just if you want to know more about it, you can go ahead to documentation, Python documentation, and see. Okay, now I forgot to talk about Boolean data type. So let's see actually what are Boolean. So I'm going to create one NumPy array, np dot array, that's a 2 4 6 8. Oh shit, I haven't imported it. Import NumPy as np. Okay, now booleans like it. Let's say I want all the values from this x variable that are greater than 4. X greater than 4. See, it provides us false, false, true, true. And if you again store it in another variable, let's say b. Okay, now data type b dot d type, it's Boolean. So NumPy has another data type, is called Boolean, and this technique is also known as fancy indexing. So what is this? It's called actually fancy indexing. Because you can arbitrarily or randomly select some elements from your array. Okay, now I don't know which are those values. I just know false, false, true, true. So now don't need it. To see those values, just embed it within a square bracket and provide x in front of it. Let's see. 6 and 8. And this practice is known as masking. You can say it's actually a mask. Our mask is 6 8. Now what about if you want to provide more information, like range of values, 10, 11, 16. Okay. Now let's say we want to see all the values of x that are greater than 2 and less than 10. So let's see what it returns. It provides us, actually returns an error, value error. So, and this whole error is all about this AND, because we can't operate here the Boolean AND OR. We have to provide here a bitwise operator, that is, for instead of AND, just you have to provide this AND, and we are going to enclose them within brackets. Now let's see, it's executed. True, false, true, false. Again, if you want to see those values, just embed them within a square bracket and see, these are the values within this range. Okay, that's all about fancy indexing or Boolean. And Booleans are actually true, false. Let's say is there, it's true. See, I have written this in uppercase T. If you write it in lowercase, Python doesn't know what it is. So you have to write it in uppercase. True. So Booleans are true or false. Okay. That's it. So that's all about fancy indexing. Now we are going to see what a dictionary in Python. Say dictionary, D-I-C-T-I-O. And dictionary is actually a fundamental data structure in Python, where we use it to store pairwise data like keys and values. What's name, let's say name Tom, age 32, height 72 inches, something like that, pairwise. So let's say my dictionary, I want to write a dictionary, DC is equal to, so we construct our dictionaries using these curly braces. Okay, now the first element is called keys. That's a name, and then we provide a colon. To that you are going to provide the name. So let's say it's Tom. Fine. Again, within quotation, age, let's say 32, and height, it's 72 inches. Tall guy. No, 70. Okay, let's see. Oops, what is it? Name Tom, age, height, everything seems good. Oh, I forgot to give the comma. That's it. Oops. Name Tom is not defined. Oh, it's a string. Sorry to waste. But it's actually a good thing to figure out what errors are you encountering. Okay, that's it, fine. Now let's see our dictionary. See, name Tom, age 32. Now if I somewhat like indexing, let's say name, it will give me the name, and you can modify this dictionary also. Okay, now if I say dc dot keys, keys, to see all the keys, name, age, and heights are here. And if you say dictionary dot values, you will see all the values, Tom 32, 72. Now we are going to use a for loop to print them at least, I mean, in a good looking format. Okay, items, it will return all the items, that is pairwise. Name is Tom, age is 32, height is 72. So let's see, for I in dc dot items, actually in items I have my keys, also my values. So for k and v in dc dot items, print what? Print KYS. No need to do that, just K and V. See, name Tom, age 32, height 72. Like, you know, I can do something else like KYS, keys are a comma, then K. Okay, now let's say values are see keys and this name, but the appearance is a little bad. Okay, now let's see what I can do. Okay, now keys are name, keys are age. I cut. Okay, this is the first key and value pairs. Keys, values. Okay, that's all about dictionary, and I can change it to a series object, but for now don't bother with that. Okay, now we have done some basic things. Now let's go to how to build a function by your own in Python. Let us define a function. It's define a function and name it. Give a name to your function. You can give any name you want. Let's say you're going to, let's see, my function. Okay, now in parentheses you can give arguments or input variables, some inputs. You can provide 2, 4, 3, as many as you want. Let's say x and y, 2 variables or arguments you want to provide, and what you want to return, and return x plus y. Okay, now after that, to run or execute this function you have to call this function. So how do we call this function? Just use this name, my function, fun, my fun, and in parentheses provide the x and y values. Let's say x is 2, y is 3. Okay, and output is 5 because we wanted to return x plus y, and that is we wanted to add them up. So now if you want, you can store this value in one variable within this function and just return z. It will be the same thing. Oh, what's the matter? oh, it's just what. Okay, I think now it's fine. Now we can do some more things, like we can multiply them by 2. Let's multiply them by 2 and return z. We can, in this function, we can also add some more variables, like n is equal to 100, y is equal to 4, and we're going to, sorry, not y, we have already given our y, so b is equal to 4, and our equation is b plus x plus y divided by this n and then multiplied by 2. See, just the output. So functions are pretty useful in Python. You will use many times, and actually you'll use it pretty sure. You'll absolutely use it. Okay. Now there's another function called lambda function, and lambda functions are actually limited. Let's see actually lambda functions. What are LAMB lambda LAM? What is this lambda? BD lambda. Then here you are going to provide your arguments, inputs x comma y. What we did here, but first x comma y, then what? Now our equation, we want the output just like x plus y. See, this is our inputs, these are our inputs or arguments, and this is our equation. Okay. Now if you want to execute this lambda function, you have to store this function in a variable. Let's say it's z. I'm going to store it in z. Now to call this function, you have to provide what? Z, then in parentheses the values of your inputs. X is, let's say, 2, y 3, and it will give you 5. See, pretty simple. But here you can provide only one expression, that is, you can't use for in defining function, our user function. This function you can use pretty anything. You can make a huge equation here, but in lambda function you can't do that. It's limited to just one argument. You can use if something is that, return that, else something else, no more than that. But in defined function you can use if, elif, else, then many things you want. So lambda functions are actually limited, but it's quite useful in data pre-processing tasks. Okay, you'll get used to it when you use it frequently, but now maybe it's a little tricky to you. Okay, so I think that's it. That's all about our basic Python for data science. If you have come to this point, congratulations, and try this every day, actually at least 5 days a week for 1 hour or 2 hours a day. Then after, let's say, what, maybe 2 months, 3 months later, you will be able to write functions or if else for loops functions by your own, but you have to practice more and more. Okay, now I could include some more things like oops, but I believe at this stage these things are not essential for you. And there are many more things I could include or I have forgotten to include. You can search those things, find those things in pandas or Python's documentation actually. So okay, that's it for now. I think you have found this video helpful. If you find this video helpful, please subscribe and like, and I'll see you in another video.